And welcome back, Algebra 1 students. Time now to go over section 7.3, the exponent chapter, and this section is on exponential expressions raised to an exponent. Really like this section. It's kind of got a fun shortcut that I want to go over. It's a simple rule, but it starts out simple, but things get kind of tricky pretty quickly. So here's the basic rule I want to go over, and here's how it works. If you have an exponential expression, we'll say a to the m, but around it in parentheses, you then raise it to another exponent. So sometimes we call these exponents raised to exponents. What is the rule? Well, the rule is you just multiply your exponents. Now, it's really easy to get confusing this section with 7.2, where when you're multiplying and your bases are the same, you add your exponents. But this section, you multiply your exponents. It's really kind of weird. So why is there a difference? Well, I want to show you how there is a consistency here that you can be confident in. So I want to expand just this question right here, x squared cubed. And so why is this x to the sixth? Because that's what the rule says it should be. So all I'm going to do is do this the old way using the rule. So I'm just going to expand this. So the 3 is talking to x squared and saying represent yourself with multiplication 3 times. So if I were to expand this, this means it's x squared times x squared times x squared. Now if I apply the rule from the prior section and I said, okay, if I'm multiplying and my bases are the same, I'm going to add my exponents. 2 plus 2 is 4 plus 2 is 6, so this would equal x to the sixth. So this rule right here is justified, and it's actually just a shortcut. It's kind of a cool little shortcut rule so that you don't have to do this. If you'd like, you could expand every one of these, and you're going to be using a lot of paper to do a homework problem, or you can take advantage of a shortcut. Now, every single shortcut that exists has a full mathematical proof behind it and justification. Now, depending on how you're wired, some students like to see that reasoning, and some students don't care, and they're like, just tell me the easy way to do it. So here is the explanation, but most students gravitate toward this nice little cool shortcut rule. That's really all there is to it, and now it's just time to look at all the examples and the little curves, twists and turns they could take as we go. So let's just take a look at a few examples. Well, this is real similar to the one we just used over here, but instead of x squared cubed, here it's x cubed squared. But it's actually the same answer. I'm going to multiply my exponents. And on this one, I wasn't planning to do this, but I am now. I'm just going to actually write this the long way. Well, this would be x cubed times x cubed. I'm going to add my exponents, and this would be x to the sixth. So 2 times 3 is 6, or you could expand it. Let's look at a couple more. How about 3a to the fourth squared? Well, now right away it's starting to get a little tricky. This 2 is communicating to everything in parentheses. So actually it's going on 2 times 4 is 8, but it's also going on to this. Now, I regularly have students use the term distributing. And they say, do you kind of distribute the 2 onto everything? And that's not a bad way to think about it. Technically speaking, you're not distributing, but I totally get what you mean. So the intermediate step here, which you can write if you need to, the 2 is coming onto the 3, so technically this becomes 3 squared times a to the 8th. You probably don't need that intermediate step, but if you do, that's fine. And then you just simplify and say, oh, well, 3 squared is 9, and this will be 9a to the 8th. Okay? Usually these are friendly enough values you can do those in your head. So what happens when I have multiple things inside? Well, you just have to make sure you put the exponent on both terms inside the set of parentheses. How about this one? Well, what you guys are going to see is you're going to be expected to know some perfect cubes. We tend to stop at 5, actually. But if we put this and we bring this in onto both exponents, I'm going to have 5 to the third power. 5 times 5 is 25, times 5 is 125. So I'd say, okay, it's going to be 125. And then this was b to the first, so 1 times 3 is 3. So I'd have 125b cubed. That's how the rule works. So you guys know if there's no exponent, it was a 1. It's implied. There actually is one, but it's just not written. Okay, so let's see what happens when we get a little more complicated. What happens if we have all sorts of stuff inside? Well, it's the same rule. We're just going to put this 5 onto every single thing. And if the exponent's 1, we're going to multiply. Well, this is 2 to the first, and this is n to the first. 1 times 5 is 5, so 2 to the fifth, that's 1. We tend to want you to know your base of 2 to a pretty high exponent. 2 to the fifth is one you want to have memorized. You can always run through it if you need to. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it is 32, and now we'll look at m. 3 times 5, m to the 15th. 1 times 5 is 5, so we have n n to the 5th, and then p squared, 2 times 5 is 10, so we will have p to the 10th power. Scoot this over. And there we go. All right. So most students are like, oh yeah, I guess this works pretty simple. Nice. Well, what could be hard about this? Well, here's your first little mini curveball. What happens if your exponent's negative? Well, if your exponent's negative, the rule still works, but there's some stuff that comes up here that I'm going to look at in our next couple examples. But if we just follow the rule and you say, I don't know, I don't like this negative exponent thing, you can still apply the rule and then we'll fix it. So I'm going to say, well, this is going to be 4 to the negative 2, and this is going to be x to the negative 6. And then at this point you could say, well, I can't just leave it like that. I got to move these negative exponents because I don't know what this means. And you could say, oh, well, I'm going to move 4 to the denominator and x to the denominator. And you would say, oh, well, I'm just going to simplify it to make it look pretty. And I'm going to leave a 1 in the numerator, and 4 in the denominator is 4 squared. And then this would be 16x to the 6th. That would be fine. There's another approach to this that we'll look at in just a second. So there's the rule with multiple examples, and let's just keep going. And the negative exponent oftentimes creates some questions that I want to go through with you. So if you have 4x to the x cubed to the negative 2 versus 4x cubed to the negative 2, I'm going to do these problems twice, and I'm going to show you how you could do them 2 different ways. Now, if we look at this one the same way we had this one here, you could just say, well, I'm going to bring this in and do it just the same way here. It's the same question. And I'm going to say, I'm going to bring this in, and I like saying 4 to the negative 2, x to the negative 6. I then move them, and this becomes 1 over 16, x to the 6th. That is the one approach. But would it be okay to do it a slightly different way? Well, let's take a peek. Does this seem legitimate? Could you say negative 2, whatever's in here, has to go to the denominator? So what if you said, I'm going to move this entire thing to the denominator, 4x cubed, and now it's to the positive 2. Would that have been okay? The answer is yes. And then, now that it's down here, could I make this 1 over, could I make this 4 squared x to the 6th? And then could I simplify it and say, oh, well, that's going to be 1 over 16 x to the 6th. It sure looks like I got the same answer. I got 1 over 16 x to the 6th here, and I got 1 over 16 x to the 6th. Both of them are acceptable, but I'm going to give you some advice. If what is inside of here is not a fraction, or everything is in the numerator, it's a good idea to go ahead and perform the rule first. If what's in here is a fraction, there's some other approaches that you can use that I'm going to show you on my next example. But both of them are legit. Let's look at this next example. What if it is a fraction? Well, this is where things get a little bit weird. Just draw a line here so we don't get confused. All right. So what if we brought this in to everything? So I'm going to bring this negative 2 onto everything inside my parentheses. Some of you would look at this and say, oh, well, that's going to be 2 to the negative 2, x to the negative 2. I need to put it on the denominator, and that's going to be 3 to the negative 2. That's 100% true. Then at this point, you would say, well, I have to move them. I can't keep them positive. And you would say, I'm going to move 3 to the negative 2 to the numerator. Pretty good idea. And you would say, oh, well, that's going to be 3 squared. And I'm going to move 2 to the negative 2 to the bottom. That's going to be 2 squared. I'm going to move x to the negative 2 to the bottom, and that's going to be x squared. And you would clean those up, and you would say, oh, well, I guess my final answer is going to be 9 over 4x squared. 100% solid way to go. Okay? But what if you were this kid and you just said, well, wait a second, I have a fraction to the negative, I got to move that to the denominator. Look at how messy this becomes. If you decide to move this to the denominator, look at this mess. You then go, okay, well, I guess this is 2x over 3 in the denominator squared, and I have a 1 here. Now, in general, whenever you've got fractions over fractions, you're headed down kind of a complicated road. We do this a little more in later math classes, but once you do this, you have a fraction in the denominator that's then going to have to be flipped up. Going this approach is not, I don't recommend this. I don't recommend making this exterior exponent positive. That tends to not be the way to go. There is another strategy for this I'll show you in just a little bit, but I recommend, even though this can get you to the correct answer, I don't recommend doing this. It leads to a lot of confusing steps. If you have a fraction, I recommend bringing this in the way I did here, or another shortcut I'm going to show you here in just a bit. Up above here, this is where either of them was okay, but the difference is this was a term that was already exclusively in the numerator. But when you have a fraction, trying to make your exterior exponent positive is just a confusing way to go. I don't recommend it, but it would work. All right, so let's take a look over here. What happens if you have a fraction raised to an exterior exponent? And you're not going to do this, but the question becomes, what should I do first? Should I bring in my exterior exponent like I did over here, or should I clean up the inside first? Get this question a lot. I really like this one because it shows you kind of the variety you can do. And I'm going to do them both ways, and I don't really have a good answer to which one you should do first because it really depends. I'll have class pretty split on this one, which one they liked better. So on this one on the left, I'm going to go ahead and bring -1 in, so it's gone. And then we'll start cleaning it up. So I'm going to move the outside in first, and then we'll see what happens. So if I bring my -1 in, following the rule, all my exponents are going to change sign because it's only a -1. So I'm going to say, well, this becomes 2 to the -3. This becomes a now to the +2. On the bottom, this becomes 4 to the -2. And I have b to the +3. Okay. Well, now I'm just going to move what needs to be moved. Well, these negative exponents, I have to move those. So I'm going to move the bottom up and the top down. So this 2 to the -3, I'm going to move to the denominator. So that's going to go down here. And I'm going to move the 4 to the -2 up top. So I get 4 squared. The a squared and b cubed get to stay put. Now I'm just about done. Now 4 squared is 16. So I have 16a squared over 8b cubed. Cube not showing up too good there. And then I can reduce that. That reduces kind of nice, and I wind up with a final answer of 2a squared over b cubed. Solid answer. Not a bad approach. But maybe you're this kid where you looked at this mess inside here and you're like, oh my gosh, look at what's inside there. That's crazy. I got to clean up the inside. I'll worry about the exponent second. Let's go ahead and do that. So you decide to do first inside. So you look at this, and I'm just going to draw this here so we don't confuse our steps. So I'm going to clean up the inside first. I'm going to say, well, that looks like it becomes 8. And I'm going to move a to the denominator. So I'm going to move a down, and that's going to be a squared now on the bottom. And then I have, on the bottom, I have 4 squared. That's 16. That's fine. Oh, and b to the -3, I have to move that to the numerator. Okay? But I still have this -1 out there that I have to deal with. So then I'm going to clean up the inside and go, oh, well, this cancels here and it gives a 2, and you would be looking at this step and you'd say, looks like I have b to the -3 over 2a squared raised to the, whoops, sorry, I said -3, b cubed over 2a squared, the entire thing to the -1. Now you would say, all right, the inside's all clean, I'm all good. Now I'm going to bring this -1, and that's going to change everything. You'd say, well, now this is b to the -3. This becomes 2 to the -1, a to the -2. And now you move everything. And you just say, oh, well, now you just got to move them to where they go. And you'd say, well, 2 goes up with the a, so 2a squared over b cubed. And you'll notice I wind up with the same answer either way. Now, again, there's not a right or wrong way. Depending on how you're wired, one of these resonated with the way you think, and you're like, oh, yeah, that made sense to me. Now, for the way I'm wired, I actually wouldn't have done this either way. I'm going to show you a cool little shortcut on my next board. But before I go to that one, I just want to recap here at the top here, exponents raised to exponents. And we just take advantage of this rule. It's a shortcut of a rule you already know about when bases are the same, you add your exponents. So this little trick right here, this little approach right here, I actually have another way to do this that has to do with kind of a shortcut rule that makes life kind of nice when you have an exponent of -1. So let me overlay this, and we're going to take a look at this and wrap up real quick. All right, and here's how this works. What happens when you have a fraction to the -1? Well, here's the cool shortcut. A fraction to the -1 actually equals the reciprocal. And the question is why? So 2/3 to the -1 actually equals 3/2. Well, why is that true? I'm going to show you. If I have 2 over 3 to the -1, I'm going to bring in the exponent. And this would actually be 2 to the -1 over 3 to the -1. Well, then I have to move them to where they're positive, so the 3 comes up, and that would be 3 to the first, and the 2 has to go down. It's 3/2. So this little rule is just a shortcut that saves you a little bit of time. And so whenever I see negative 1 to the an exponent of negative 1, I almost always just rewrite the problem with the reciprocal. Exponent's done, and I move on from there. And you can actually expand this a little bit farther. I want to show you a quick example with this one, though, here. For example, let's say you had something a little more complicated. So let's pretend you had 3 squared a to the negative 3 all over, we'll do this other one from before, b squared over b to the negative 5. And the entire thing was raised to the negative 1. Well, instead of worrying about the last question about what should I do first, my first step is this. And I just say, oh, I'm just going to rewrite it. I'm going to say I'm going to rewrite it as the reciprocal, and then I'll clean it up. So I just know, I just say, oh, it's b squared to the minus 5 over 3 squared a to the negative 3. And then I clean it up from here. And I say, oh, well, that's going to be 16. B to the 5th goes down, here with the 9. B to the 5th goes down, and I see a cubed comes up. That's how I would do that. I'm going to expand it to a more generalized rule, and here it is. If you actually have a fraction to a negative exponent period, it's just the reciprocal to the positive exponent. I'll show you a cool example. What if you had 4a cubed over 5b squared to the negative 2? Well, it actually equals the reciprocal to the positive exponent. And why does this work? Well, I'm going to show you how we could have used our old rule just to justify it. So what I'm going to do is do this the old way. What if I just brought negative 2 in? So I'm going to do that this way right here. That actually would have been 4 to the negative 2, a to the negative 6, all over 5 to the negative 2, b to the minus 4. Then I would have to move everything. And I'd say, well, I have to move everything from the bottom has to go up. That's going to be 5 squared b to the 4th. Everything on the top has to come down. That's going to be 4 squared a to the 6th. And then if I clean that up, I just say, looks like I'm getting 25 b to the 4th over 16 a to the 6th. But look how much time I save myself if I just flip it and make it positive. If I flip it and make it positive, I then can bring the 25 in. I can bring the 2 onto the 5. And I go right here to 5 squared b to the 4th, all over 4 squared a to the 6th. And then I can just apply my exponents to my bases that are numbers, and I get 25 b to the 4th over 16 a to the 6th. And once again, you get the same answer either way. So if you like to just bring this in, and you can do a lot of steps, this is a really handy shortcut that just makes things pretty quick. In general, we don't like negative exponents, so these are two kind of cool rules. You want to get rid of them quickly, just flip the fraction and make the exponent positive, and then you can bring it in, because then you could clean it up if you'd wanted to. So back to this question right here. What should you do first? This is why I said I wouldn't do either of these first. I actually would have flipped it to make the exponent positive 1. I just would have flipped it, and then I would have cleaned it up. So, but whatever makes sense to you, because there's a lot of subtleties with this one that it's you can see just how cluttered the board is now in all sorts of steps. Exponents take a lot of repetition to get really good at it. So that's 7-3. Hope you like that. Good luck with that homework and practice, and we will see you next time. Thanks.